Welcome to all of you in this video. In this video, we will talk about Mendeleev's periodic table. Dmitry Ivanovich Mendeleev was the Russian scientist. When he started his work, only 63 elements were known. He arranged all the known elements in the increasing order of their atomic weight and placed the elements with similar properties one below the other. And he observed that the elements with similar properties occurred after fixed interval in this setup. On the basis of his observation, he formulated his periodic law. He said that the properties of elements are the periodic functions of their atomic weights. On the basis of this periodic law, he formulated his periodic table. Now, the periodic table of Mendeleev was first published in a German journal in 1872. In Mendeleev's periodic table, every vertical column was called group and every horizontal row was called period. Now, at the top of every period, a general formula for the hydrides and oxides were written, where letter R was used to represent any of the element of the group. Now, for example, if we say that methane is the hydride of the carbon, so here CH4 was represented as RH4. We also know that carbon dioxide is the oxide of carbon. Here CO2 used to be represented as RO2. So this was the kind of arrangement or organization of Mendeleev's periodic table. Now, one more thing. Mendeleev decided the location of elements in the periodic table on the basis of the chemical compounds formed by them with the oxygen. For example, let's say that R is an element and it forms a compound with oxygen in the manner R2O. Now, we know that R may be represented here by hydrogen. It can also be represented by sodium. So, when we analyze the compounds water and N2O, we come to know that the valency of sodium and hydrogen is 1. So, hydrogen and sodium both were kept in group number 1. Similarly, again, if R represents any element and it forms a compound with the oxygen in the manner RO, so here R may be represented by magnesium. It can also represent calcium, and by analyzing magnesium oxide and calcium oxide, we know that the valency of magnesium and calcium is 2. So both of them were kept in second group or group number 2. So this was the whole setup of Mendeleev's periodic table. Now let's come to the advantages and achievements of Mendeleev's periodic table. That what was the advantages and what was the achievement which was registered by this effort of Mendeleev. Now let's see. The first achievement or the first advantage was that this periodic table was used in the study of elements. We know that periodic changes have been observed in the elements of the same period, and we also know that the elements of the same group, they have the similar properties. Now, if we know the property of one element of a group, we can predict the properties of the other elements of the same group. So, this periodic table was highly useful in the study of elements. Now, second advantage or second achievement of this periodic table was that it was useful in discovery of new elements. So, what happened? Mendeleev left some gaps in his periodic table. How genius was he? He left some gaps, and instead of looking at them as defects, he predicted the discovery of elements in those boxes. And he used a prefix eka to the name of the preceding element to name the newly discovered element. So in this way, the blank after boron, that means the element which was expected to fill the blank after boron, was called eka boron, which was later discovered to be scandium. Similarly, the blank or empty box after aluminium was called eka aluminium. That means the element which was expected to fill that gap was called Aka aluminium, and later is discovered to be gallium. Similarly, the blank after silicon was called Aka silicon. That means the element which was expected to fill the blank after silicon was called Aka silicon, and later it discovered to become germanium. So scandium was earlier called Aka boron before its discovery according to Mendeleev, and gallium was called Aka aluminium, and germanium was called Aka silicon before their discoveries by Mendeleev. It was a great achievement that someone is leaving a blank space and predicting that something will be discovered later, and the things are discovered on the same lines. It was a great achievement that he was a scientist who could predict the elements. Now the next achievement was correction of disputed atomic weight. So here the elements like beryllium, okay, so the atomic weight of beryllium was corrected on the basis of its valency. Earlier it was thought to be trivalent, but on the basis of the valency it came to be known as divalent, and it was kept between lithium and boron. So similar to the beryllium, uranium and indium's atomic weight was also corrected. This was another achievement which was very great. The next achievement is the place for inert gases. Now see, Mendeleev's original periodic table did not have any place for inert gases like helium, neon and argon because they were not discovered at Mendeleev's time, but he had left the place for it as well. Now later, after their discovery, the scientist Ramsey, okay, so make sure that you do not read it as Ramsey, it is Ramsey. So the scientist Ramsey inserted a new column which was called the zero group and accommodated all the inert gases which are also called noble gases. So this was another achievement of Mendeleev's periodic table. So after achievements, let's come to the limitations, that what were the things which Mendeleev could not do. Now see, the first thing which Mendeleev could not do is the position of hydrogen. He could not justify, or he could not ascertain the position of hydrogen, where it has to be placed. So see, there was uncertainty in hydrogen's position. This was the first limitation in the Mendeleev's periodic table. We know that hydrogen gives positive ion like the alkali metals lithium and potassium, and it also gives negative ion like the halogens chlorine and bromine. So its place in Mendeleev's periodic table was uncertain. So there was no certainty in the position of hydrogen. This was the first limitation of Mendeleev's periodic table. The second limitation with which the Mendeleev's periodic table suffered was placing heavier elements before the lighter elements. So what happened? While arranging the elements according to their valency, it happened that some of the heavier elements like cobalt, whose atomic weight is 58.9, were placed before the elements which were lighter like nickel, whose atomic weight was 58.7. So this clearly violated Mendeleev's periodic law, where the elements were expected to be arranged in the increasing order of their atomic weight. Now the next limitation was position of isotopes. Now we have seen that in the Mendeleev's periodic law, elements were arranged in the increasing order of their atomic weight, but there was no place for the isotopes. As far as isotopes are concerned, we know that their atomic number is the same, but their atomic weight is different. So there was no place for the isotopes. It was another limitation of Mendeleev's periodic table. Now the fourth limitation was that there was irregular increase in atomic weight when moving from one element to the other. That means when elements were arranged in the Mendeleev's periodic table, the increase in their atomic weight was not fixed, it was not certain. So all these were the limitations with which the Mendeleev's periodic table suffered. So in this video, that's it. Thank you.